We are done with centripetal force. Now we will talk about centrifugal force. What is centrifugal force? It is not a real force. It is a pseudo force. What is pseudo force? See, when an observer is moving with some acceleration, so he observes that the other object is moving with acceleration in the opposite direction. Actually, he is only moving with some acceleration, but it looks as if the other object is moving with the same acceleration but in the opposite direction. So he assumes that the other object, so some force is acting on the other object in the opposite direction. This imaginary force is called a pseudo force, right? So we talked about pseudo force in detail. Now this centrifugal force is also one form of pseudo force only. See, when the object is moving in a circular path, so there is a force acting on the object towards the center, we call this centripetal force, right? So this centripetal force can be due to tension, friction, gravitational force, anything. Now if the observer, we are not observing this from outside, if the observer is in the frame of reference of that rotating frame, right? Suppose you are standing at the center of the circle, okay? Now you are rotating with that circle. Right now, for that person observing from the center, this object is not moving, right? This object is at rest because the observer is also rotating. So this object is at rest for him, which means no force is acting on the object, but actually there is a force acting on the object. What is the force? That is the frictional force, right? If this friction was not there, this object will fly away. It is the friction that is keeping the object connected to that surface, right? Otherwise, if this friction was not there, this object will move away. So there is a force acting on the object, that is the frictional force. That frictional force acts as the centripetal force here. So, but for him, this object is not moving. That means he thinks that no force is acting on the object. Okay, suddenly the friction disappears. Okay, there is no friction. So all of a sudden this surface has become smooth. Okay, so friction is not there. What will happen? So that object will not stay in that position, it will fly away. Okay, so then for him it appears, okay, so this object is moving away from the center. That means there must be some force acting on the object away from the center, but no force is acting on this object now. Actually initially there was friction, but he thinks that no force is acting, but now this object is moving because there is no force, but he thinks that now only the force is acting away from the center. You understand? So this is an imaginary force, right? For him, now this object is moving away, so there must be some force acting on the object away from the center. So that force, that imaginary force, is what is called the centrifugal force, right? See, because this person is accelerating, okay, this person is rotating, which means he has some acceleration. So this person is rotating. For him, so there is a force acting on the object away from the center. So that imaginary force is called a centrifugal force. So that is one of the pseudo forces, right? There is one form of pseudo force, right? Yes. Now what is the formula for that centrifugal force? So the same formula as the centripetal force numerically. See, centrifugal force, so it has the same numerical value, F equal to centripetal force, right? Because in the absence of the centripetal force, this object is moving in the opposite direction. If this centripetal force was there, this object, the force is towards the center. Because this force is not there, the object moves away from the center, so only the direction is different. So what is the centripetal force? So mv square by r. So same formula, mv square by r, or you can say m r omega square. So that is the formula for the centrifugal force also, right? So we wrote the same value for centripetal force, but this is away from the center. This force acts away from the center. So centripetal force acts towards the center, okay, so but this force is acting away from the center. But this is a pseudo force only. We will use this force only when the observer is also rotating, right? So we observe this in that rotating frame of reference, then this object looks as if it is moving away from the center. So some force is acting on this object away from the center. That force is called a centrifugal force. Alright, yes. So that is formula, this one m r omega square or mv square by r. Alright, so this is the formula for centrifugal force. Let's solve some questions based on this. Here we have a circular disc rotating about its axis with some angular speed omega. A block is placed at some distance r from the center of the disc. Now this block should not slip. So what should be the maximum distance r? See, if you increase the distance r, chances are that the block slides over this surface, right? That means there will be some relative motion between this block and that disc. So you have to keep the distance less. So what should be the maximum value of r, right? Maximum distance from the center. So that we have to find. Okay. So what is the force that is keeping this block in that position, right? That means what is the centripetal force, the force acting towards the center? That is the frictional force, right? So we have already done this question. So while we were discussing that centripetal force, but at that time we observed this from outside. But now we are going to use centrifugal force. That means we observe this in the frame of reference of that rotating disc only. Now the observer is also rotating. Now we have to consider centrifugal force, right? So when you observe this from outside, so no concept of centrifugal force. Now the observer is also rotating, right? Now we have to use centrifugal force. So centrifugal force is the pseudo force acting in the outward direction, right? So radially outward direction. And that force should be balanced by the inward force, right? So what is the inward force? The force acting on this block towards the center, that is the frictional force. That frictional force must be greater than the outward centrifugal force, right? If this frictional force is less than the outward force, so the object will move outward, right? Now to prevent that, the friction must be more than the outward centrifugal force, right? So that means the frictional force. See, for equilibrium, okay, for the observer, right? The observer is also, suppose the observer is at the center of the disc, right? Observing this object. That means this object is in equilibrium now. So that means the centrifugal force. The centrifugal force, that means it is the outward force that is balanced by the frictional force, should be equal to the frictional force. Okay, but what is the centrifugal force? So that is, so we know the formula, right? So m r omega square, right? So r is the radius, so m r omega square, right? Yes, that is the centrifugal force. So that must be equal to the frictional force. But what is the frictional force? So that is the static friction. No relative motion between the surfaces. So static friction. But static friction should be less than or equal to the limiting friction. So what is the limiting friction? So that is mu m g. That's also, that will give you the answer directly. Okay, so same calculation we did there also. Okay, but we use the concept of centrifugal force here, right? So that is the difference. So the frictional force, which is the static friction, that should be less than the limiting friction. So that's also, that will give you a required value of r. So what do you get? So m gets cancelled. So we get r less than or equal to, so mu g divided by, yes, omega square. That's all. So that is the answer. So our required value of r, right, the distance should be less than or equal to this. That means this is the maximum distance. If the distance is less than this, then this block will stay in that position only. Okay, yes. If the distance is more than r, it will slip, right? It will go away from that circular orbit, right? So that's all. So mu g divided by omega square, that is the maximum distance r. Okay. Here also we have a circular disc, but it has some groove from the center to the circumference. A block is placed at some distance a from the center. Now this disc is rotated, right, horizontally. Now this block will move outward because there is no centripetal force. There is no force acting on this block which will bind this block to the center, right? So this block will move outward because we are observing this in the frame of reference of the disc, rotating disc. That means there will be an outward centrifugal force. So that is the only force acting on the object. There is no friction anywhere, right? So this object moves outward because of the centrifugal force. Okay, because the observer is accelerating, right? Observer is in the frame of reference of the rotating disc. That means the only force is the centrifugal force. So force on the object is known. From force we can find the acceleration. From acceleration we can find the speed, right? The velocity. Okay, yes, let us find it. Now what is the force acting on the object? So that is only, so the force acting on the object is the centrifugal force outward. That is centrifugal force formula we know, right? In terms of the angular velocity, right? Omega is the angular speed. So that means mr omega square, but r is the, suppose you take the point, see initially the distance from the center is a. finally the distance is r, right? When it leaves the disk, the distance is r. Now we take a variable distance, right? Suppose the block is at a distance x from the center. Now then the distance is, the centrifugal force formula is mr omega square, but here mx omega square, because x is the radius now. Okay, yes, force is known. From force we can find the acceleration. Acceleration is divided by mass, so that is x omega square. So from acceleration we have to find the speed. See, this is a variable acceleration, so we can't use the basic equations of motion, we have to use calculus. So acceleration can be written as the rate of change of velocity. Okay, so dv by dt is only the acceleration, that is x omega square. Okay, now we have to do integration to get the value of v, but there are three variables here, v, t and x. All these are variables, so we have to convert this into a two variable question so that we can do the integration. When we have three variables, so we can't do integration, so we can write this dv by dt. So that is the usual method we do for questions of this type, right? So you write dv by dt as dv by dx multiplied by dx by dt. Okay, like the chain rule, right? dv by dx, dx by dt, that is same as dv by dt. So that equals, so x omega square. Now dx by dt, that is the rate of change of that displacement, right? dx by dt, that is same as velocity, so that means this is v. So v dv equals, now dx we can multiply, so x omega square dx. Now you do the integration. Okay, so initially the speed is say 0, and then finally the speed is v when it leaves that disk. So now here initially the distance x is a, that is the initial distance of the block from the center. Now finally the distance is r, right? That is the radius of the disk itself. Okay, so that's all. So let us do the integration to get the answer. So this is v square divided by 2, so that equals, so we can do the integration here. So this is omega square, this is x square divided by 2. Okay, so divided by 2 x square. Now if you substitute the upper and lower limit, so we get x square, so that means r square minus a square. So that's it. So this will give you v, just take the square root. So v equals, so omega square root of r square minus a square. So that's all. So that is the required value of v with which this block leaves that disk. Is that okay? See, simple, we found the force. But what is the force acting on the block here? That is only the centrifugal force outward. The object is moving outward, the force causing that is the centrifugal force outward. This is the force. Once force is known, we can find the velocity, right? Acceleration, velocity by using the basic calculus. Alright, so that is the answer. The speed is omega multiplied by square root of r square minus a square. Here we have a disk again with a groove along a diameter. Now a block is placed in the groove. Now this disk is moving in the horizontal direction. It's not rotating, it is moving in the horizontal direction with some acceleration. Now we have to find the acceleration of this block. Okay, now this block has acceleration in two different directions. One is, see, this disk is moving in the horizontal direction. That means along with that the block will also move in the horizontal direction, right? Yes, and also it will move along that groove also. In the direction of that groove it will move. So it will have acceleration in two different directions. But we have to find the acceleration only with respect to that disk. That means you have to observe this in the frame of reference of that disk only. So it is, now we have to use pseudo force because now the observer is moving with some acceleration. So we have to consider the pseudo force in the opposite direction. Okay, yes. Now, so it is similar to the last question, but no rotating, right? No rotating disk, right? It is only moving with a acceleration, right? Yes, that's all. So now let us consider all the forces acting on this block. Now if you observe this block from the frame of reference of the disk, now this block appears to be moving only along the groove, right? It is not moving in the horizontal direction because observer is also moving in the horizontal direction. That means the block appears to be moving only along the groove. Okay, that acceleration is what we need to find. Okay, yes, that means let us observe this. Let us consider the forces acting on the block in the normal direction. What are the forces acting in the normal direction? See, there is a normal force due to these walls. Okay, normal force due to these walls. Okay, that is this normal force. Okay, and also we have this frictional force due to the wall. Okay, wall of the groove. and also frictional force due to the floor. Okay, there are two frictional forces, frictional force due to the wall, right, the side walls, and the frictional force due to that floor, and also we have the pseudo force in this direction because the observer is, that is the disc, is moving in this direction with acceleration a, so we have pseudo force in the opposite direction. Okay, yes, so these are the forces acting on this block. Okay, now in the normal direction, normal to the wall, okay, of the groove, right, in the normal direction, what are the forces acting? So that is n in this direction, n, and also the component of the pseudo force, right, the pseudo force is ma in this direction. You have to take its component, right, so ma, so that angle is 90 minus theta, right, ma sin theta, right, so this n must be equal to ma sin theta. Okay, so that's all. So that is normal force due to the walls. Okay, done. Now we will consider the forces acting on this block along that groove. Okay, what are the forces acting on the, see, along that groove? What are the forces acting on this block along that groove? So that is the component of ma, right? So ma is the pseudo force. Now we have to consider its a component, right? So if you take its component, so what do you get? Ma cos theta, right? So ma cos theta, yes. So that is the component of pseudo force along the groove, okay, ma cos theta, minus the frictional force. But there are two types of frictions. One is friction force due to that say side wall, we can say side wall. Due to that side wall we have friction, and also we have frictional force due to that floor of that groove. Okay, floor of the groove, because this disc is horizontal, right? So due to the floor, so we have frictional force, and also due to the side wall, so two friction forces, right? Yes, so that must be equal to, this is a total force, so that equals mass times the acceleration. So the acceleration you can take am, okay, that is the acceleration of that block. Okay, so let us simplify this. So this is ma cos theta. What is friction due to the side wall? That is mu multiplied by the normal. Mu multiplied by the normal, but normal due to the side wall, that is what we found here, normal, right? So ma sin theta, so that can be substituted here, so ma sin theta. Similarly, minus friction due to the floor, so that is mu multiplied by normal due to the floor, so that is same as the gravitational force, right? So the upward normal is balanced by the downward gravitational force, right, the weight of the object, so that means mu mg, right? So that can be written directly, okay, mu mg. So that equals mass times the acceleration. Okay, so that's all. So simplify this, you get our required acceleration of that block. Okay, am. So that's it. So am can be written as, you can divide by m. Okay, if you divide by m, so we'll get a cos theta. Okay, a cos theta. M is divided. So mu a sin theta minus mu g. Okay. So that's it. So let's simplify this. So a cos theta. So a cos theta. So cos theta value is known. See, theta is given, and actually tan theta is known, right? So tan theta is, so tan theta is 3 by 4. If tan theta is 3 by 4, we can use the triangle here. So if tan theta is 3 by 4, sin theta is 3 by 5, and cos theta is 4 by 5, right? So that can be written directly. So 4 by 5, and mu value is also given 2 by 5. Okay, multiplied by again sin theta is 3 by 5, this a is taken out, minus again mu is 2 by 5, and g can be taken to be 10. Okay, so what is this value? Okay, so this is a multiplied by, so what is this value? 20 minus 6, so it is 14 divided by 25 minus this is 4. Okay, so that equals, so a multiplied by 14 by 25 minus 4, but a is also given in the question, right? 25 meter per second square, right? This is 25, so this is 25 multiplied by 14 by 25 minus 4, so that equals, so this gets cancelled, so 10, so 10 meter per second square. Okay, so this 25 is the acceleration of that disk. Okay, we have taken that as A, so A is given 25. So that's our 10 meter per second square. This is the acceleration of the block, not the actual acceleration of the block, the acceleration of that block with respect to that disk. That means only along the groove it has some acceleration. It also has some acceleration component in the horizontal direction, right? Total acceleration can be found, but the question is only to find the acceleration with reference to that disk. That means along that groove it has acceleration 10 meter per second square. So that is the answer. Here a pendulum is suspended from the ceiling of a car moving in a circular track. That means there will be some centrifugal force in the outward direction. We observe this in the frame of the rotating frame, right? So that means there will be some centrifugal force in the outward direction. So that centrifugal force is what making this pendulum deviate from the vertical position. Suppose the angle is theta, right? That means there will be a tension force in that direction, okay? And then on this bob of the pendulum there is a force acting in the outward direction. That is the centrifugal force. Okay, so centrifugal force in the outward direction, and also mg, gravitation force in the downward direction, and tension acting in this direction. Okay, so let us consider all the forces. See, so what are the forces acting on that, right, pendulum, right, the bob, in the normal direction, right, vertical direction. So in the vertical direction, we have the component of t cos theta, right, t cos theta in the upward direction. So t cos theta, and that is balanced by the downward, okay, mg, okay, that equals 0, okay, no vertical motion. Okay, now in the horizontal direction, in this direction we have the component of tension, that is, so this is horizontal direction, or towards the center. Okay, anyway, so horizontal direction. So towards the center we have the component of tension, so that is t sin theta, right, 90 minus theta there, so t sin theta, and outward direction we have that centrifugal force, so that is minus m, okay, v square divided by r, so that must be equal to 0, okay, because the object is not moving. For an observer in the rotating frame, the object is at the same position, right? That means no outward force, right? The total force is 0, no outward acceleration, because the inward force is what? That is the component of tension, inward force, that is balanced by the outward centrifugal force. Okay, yes. So that's also, we have to just simplify this. So t cos theta, we can divide it, right? Sin theta divided by cos theta, so that is tan theta, that equals this divided by this, so m gets cancelled, so v square divided by rg. So that's also, that is the value of tan theta, right? But I think the values are given, right? So v is given to be 10, so this is 10 square divided by r is also 10, so g can also be taken to be 10, that means simply 1. So tan theta has value 1, so that means the angle theta is 45 degrees. So that's all. So 45 degrees, so that is the angle made by the pendulum with the vertical. So when you consider the outward centrifugal force, right? So you don't need to use the idea of centrifugal force, right? Simply centripetal force concept is enough, right? What is the formula for centripetal force? That is mv square by r. That centripetal force is due to the tension, the component of tension force. So mv square by r is t sin theta. So that's what we've used already, right? So when we did questions based on centripetal force, we used the idea of centripetal force. What is the force that creates that centripetal effect? mv square by r, that is here t sin theta. Okay, but here we use the idea of centrifugal force, both are same here. So the inward force is t sin theta, the outward force is the centrifugal force, so they balance each other. Okay, so that's all. Okay, but this is same, right? Vertical forces, so that is 0. So anyway, so this angle is 45 degrees. Okay. Here a car is moving in a circular track. We have to find the maximum speed of the car not to skid. That depends on the traction, right? The friction between this car tires and the road. See, this speed has to be within certain limit, right? If you increase the speed, maybe this car will fly away, right? So move out of that circular track. Okay, so what is that maximum speed? That's what we need to find. So mu is given, right? The frictional coefficient is given, so let us find it. See, So now we will observe this in the circular frame only, the rotating frame. Okay, that means there is an outward centrifugal force, and the inward force should be more or equal to the outward centrifugal force, right? What is the inward force? That is the frictional force, right? If this friction was not there, this car will not stay in that circular track, right? The friction is what keeping the car in that circular track, the inward friction. Outward centrifugal force is balanced by the inward frictional force. See, the centrifugal force. What is centrifugal force? So that is mv square divided by r. So that is the centrifugal force. So that must be equal to the frictional force. So these two forces balance each other. That is why the car is at the same distance from the center. Okay, yes. Now, what is friction? That is the static friction. In the radial direction, it is a static friction. Okay, so no slipping in the radial direction. So that means it is a static friction. So static friction should be less than or equal to the limiting friction, right? So that is mu mg. So mv square by r is less than or equal to mu mg. So that will give you, so m gets cancelled, mu rg. So v must be less than or equal to mu rg. So that's all. So this is the maximum. V must be less than or equal to mu rg. That means the maximum value of v is mu rg. So that is the maximum limit. So if you increase the speed further, this car will go away from that circular track. Okay, so that is the maximum speed. Okay. Here we have a smooth road, that means no frictional force, but this road is not flat, not horizontal. It is inclined at some angle theta to the horizontal. That means the outer edge is elevated, right? That is at a higher position. That means it is not a flat road. So here the centripetal force is due to the component of normal reaction. So there is a normal reaction between this car and that road. Okay, suppose it is a flat road. Okay, the normal will be in the vertically upward direction. It has no component in the horizontal direction, no inward force because of the normal force. But here the normal is inclined at some angle. You can take the component of the normal in the inward direction, and that component is what is the centripetal force. That is because of that normal reaction that the car stays in that circular track. Okay, yes. So the normal component of the normal in the horizontal direction, inward direction, is the centripetal force. Okay, so that normal force should be balanced by the outward force, that is the centrifugal force, right? So the centrifugal force outward and the inward force is the normal component. So these two should balance each other. Okay, see, what is the centrifugal force? So that is m. Okay, so same formula, mv square by r. So that is the formula for the centrifugal force. That must be equal to the outward normal force, inward normal force. So n, its component, right? N sine theta, right? 90 minus theta there. So n sine theta. So the inward force and the outward force, they balance each other. That's why it stays in that position. Okay, the car. Okay, so that is done. So this is in the horizontal direction. Similarly, we can consider the vertical direction. What is the vertical direction? The component of normal in the vertical direction. So that makes angle theta. That means n cos theta. So that is balanced by the downward mg. Okay, n cos theta minus mg must be equal to 0. Okay, so that's it. So we have to simply we can eliminate this n. So you can substitute this value of n here in this equation. So this will give m v square divided by r equals, so n, but that n can be substituted from here. So that is mg divided by cos theta multiplied by sin theta. Okay, so m gets cancelled. So we are getting v square is equal to rg tan theta. So if you take the square root, so v equals square root of rg tan theta. So that's all. So that is the speed of the car. Okay, yes. So for this speed, see here it is not the maximum or minimum speed, it is the exact speed. Okay, exact speed. Okay, for this speed the car will stay in that position. If you increase the speed, the car will slip to the right. Okay, it will move upward. Okay, it will move away from the circular track. If the speed is less than this speed, the car will slide down. Okay, it will fall down. Okay, towards the okay, the component of the gravitational force will be more in that case, which means the car will slip downwards. If you increase the speed, it will move upward. But if you keep the speed exactly this one, okay, root rg tan theta, only then the car will stay in that circular track. Okay, so that is the answer. So root rg tan theta. Okay. Here we have both friction and banking. So it is a combination of the last two questions. So here the centripetal force can be due to the normal reaction and also due to that frictional force. Okay, so let us use both these forces. Okay, here what are the forces acting on this car? See here the normal force in this direction, okay, and also mg in the downward direction, gravitational force, and we have the outward force, that is the centrifugal force, okay, mv square by r, and we also have the frictional force. But what is the direction of this friction? See, there are two cases. If you want to find the maximum speed, when you find the maximum speed, okay, which means if you apply maximum speed, what will happen in that case? The car will try to skid in the upward direction, okay, in this direction. So friction will work against it, so friction will be in the downward direction. But if you go with the minimum speed, so the car will try to slide down, so friction will prevent that, so friction will be acting in the opposite direction. So for minimum speed or maximum speed, we have to consider the direction of friction differently, right? Yes, so let us first consider the maximum speed, okay, V max. To find V max, we are finding the maximum speed. That means the speed is maximum, the car will try to skid in the upward direction. So friction will be in the opposite direction. Okay, yes, let us calculate this first. Now vertical direction, let's consider the vertical direction. What are the forces acting in the vertical direction? Okay, the component of normal in the vertical direction, that is n cos theta. Okay, that angle is theta, n cos theta. In the upward direction, n cos theta. And in the downward direction, we have mg. Okay, so minus mg. Okay, and also we have the component of the frictional force in the downward direction. Okay, what is that component? That is F. F is mu, okay, mu multiplied by normal, right? Mu n, F is mu n. That component you have to take. So F sin theta, so mu n sin theta. So that is in the downward direction. So minus mu n sin theta. This is the total force in the vertical direction, that is 0. Okay, yes, so that is in the vertical direction. Similarly, so we will take that horizontal direction. What are the forces acting in the horizontal direction? Okay, in the horizontal direction, so no gravitational force. The component of the normal in the horizontal direction, n sin theta. Okay, 90 minus theta, this angle, n sin theta. So n sin theta. Okay, yes. Now we have the component of the frictional force. So what is the component of frictional force? So that is F cos theta. F cos theta. F is mu n cos theta. So that is also in the positive direction. So plus mu n cos theta. This is a frictional force multiplied by its component cos theta. Okay, done. Is there any other force? Now outward we have that centrifugal force. Outward centrifugal force. So minus mv square by r. These are the forces, so that must be equal to 0. Okay, yes. So that's all. You have to solve this to get our required value of v. Right? V is what we need to find, but we don't want n. So n can be eliminated. So how to eliminate this n? So we can divide these two equations. We can divide n, but you take this mg to the other side and then divide it. Okay, so what will you get? So let me write it. So n cos theta. N if you take out, you get cos theta minus mu sin theta. That equals mg. That is the first equation. This is the first equation. Similarly, you can take n out from the second equation. So we'll get sin theta plus mu cos theta. So that equals mv square by r. mv square divided by r. Now what do? You can divide. So this is the first equation. So this is the second equation. Okay, now we can simply divide. We don't want n. So divide it, you will get our required v. So if you divide this by this, what is that? M gets cancelled. V square by rg, right? V square by rg is equal to this division. So divide. So v square by rg. Okay. That equals, so this division, so that is sin theta plus mu cos theta divided by, so this value, cos theta minus mu sin theta. If you simplify this, we get the value of this V, but that V is the V maximum, right? That means the maximum speed, right? So that will give you, let me write it directly. So V max equals, so if you multiply, you get Rg multiplied by sin theta plus mu cos theta divided by cos theta minus mu sin theta. Okay, so that's all. So this is the square of that, right? So then take the square root. So this is the value of V max, the maximum speed. Okay, yes. Now we have to find the minimum speed. For that, same calculation, but the direction of friction is reversed, right? So we have to take the opposite direction. So but we don't do the calculation again, right? We have the method. What is that? So when you find the maximum value, to find the minimum value, you just replace mu by minus mu. Okay, so if you replace mu by minus mu, the direction of friction is reversed. So we will get directly, so V minimum equals, so almost the same thing, Rg multiplied by, so this mu becomes minus mu. Similarly, this will become plus mu. So that is sin theta minus mu cos theta divided by cos theta plus mu sin theta. Okay, so that's all. So just replacing mu by minus mu, we get the minimum value of the speed V. Okay, do you understand? So that's it. So here we have the centripetal force due to both the normal, the component of the normal reaction, and also due to the frictional force. This total force towards the center is balanced by the outward centrifugal force. So equate them. So just a calculation. So we get the answer, right? So here it is not the exact speed. If the speed lies within this range only. Okay, I missed this square root here. Okay, so if the speed lies within that range, okay, it will stay in that circular track. If you increase the speed, it will go away, right? It will go upward. If you decrease the speed, it will slip downwards. So in this range, our required speed should lie, right? So that's all. So that is the answer, the minimum speed and the maximum speed. Okay. That's about centrifugal force. With that, we have completed the chapter Newton's laws of motion. Bye for now.